Hi, everybody. This time we're going to talk about oxidation reduction reactions. Now, this is a broad category of reactions that includes some of the other kinds of reactions that we have already talked about. Combustion reactions, burning reactions, rusting, digestion, and reactions where electrons are transferred from one compound to another are all oxidation reduction reactions. And you may have heard of oxidation reduction reactions. It is a massively important, really big class or category of chemistry. Now, originally, when someone thought of oxidation, when chemistry was still young and they were trying to figure things out, they defined oxidation as meaning oxygen was added to a molecule, and reduction was defined as oxygen was removed from a molecule. So, for example, if we take a look at iron rusting and this chemical reaction for the oxidation of iron, we start out with iron and it chemically reacts with the oxygen in the air and it produces iron oxide. Well, this was the classic and first attempt at chemistry to figure out this process. And they defined oxidation in this way, as oxygen being added to that iron molecule, producing an oxide, and they called that oxidation. As a matter of fact, oxidized is a synonym in the English language for rusting or corroding. But what chemists have found is that this process is more complicated and can be applied to other areas and other reactions. So the modern definition of oxidation reduction is this. An oxidation reduction reaction is a transfer of electrons from one compound to another in a chemical reaction. So this is the official definition of oxidation reduction. When something is oxidized, it loses electrons, and at the same time, they always come together like peanut butter and jelly. When something is oxidized, something else is reduced. This class of reaction is very often shorthanded with the name redox reaction. It's just a faster way of saying oxidation reduction. Now, this concept of losing electrons, you're oxidized, gaining electrons, you're reduced, is tricky and it's hard to remember. And so there is a memory aid that is all over everywhere. I certainly did not invent it, but it goes like this. Leo the lion says grr. And what it stands for is if you lose electrons, something is oxidized. Lose electrons, oxidized. Gain electrons reduced. Grrr, gain electrons reduced. And so this picture of this silly little lion going grrr helps you remember lose electrons oxidized, gain electrons reduced. And chemistry students all across the world spout that crazy little saying. Oxidation reduction reactions give off energy or give off heat as one of their products. That's one of the reasons they are so important. Typically, they are exothermic. Exothermic, exo means exits, thermic means heat, as in thermos bottle or thermometer. And chemical reactions that release heat or energy are exothermic reactions. Now, the opposite to that are endothermic reactions. Endo as in into, thermic again meaning heat, but this is chemical reactions that heat comes into. These are chemical reactions that feel cold. So our redox reactions are very exothermic, and that's one of the reasons that we use food and fuels, because we need that heat. When we burn wood or propane or methane or diesel fuel, when we digest food to warm our bodies or power the engine that is life. And even something like instant little hand warmers, that is actually a quick reaction where there is finely ground iron dust in there that is rusting. It is oxidizing or corroding at a very high rate of speed because of the chemicals next to it. And that is where the heat comes from in these little instant hand warmers. Endothermic reactions, the best and most common example of that is an instant cold pack. This is a chemical reaction that actually absorbs heat from its surroundings and requires that heat in order for the reaction to come to completion. And we'll get more into energy next week. These redox reactions are very important in biochemistry, very important as you study anatomy and physiology, because these are the reactions that power life, that make your brain work, that make your muscles work. Combustion does not happen in the human body because your body doesn't get hot enough to combust, thank goodness. But we still have to have the energy from those fuels, those carbon and hydrogen fuels. So how does that happen? Well, it happens via the product of oxidation and reduction. Now, oxidation and reduction can be complex, and my goal here is to simplify it. So I've created this little chart that has a lot of information packed really tight, and then we're going to use this to analyze a collection of reactions, and your goal is going to be to pick out what was oxidized and what was reduced. So let's go through both sides. When we look at a chemical reaction, we're going to try and figure out what was oxidized. The thing that is oxidized loses electrons. Remember, Leo the lion, lose electrons, oxidized. The oxidized thing becomes a positive ion. Starts off as an atom, and it becomes a positive ion because of the chemical reaction. It typically can, all of these don't have to be true, but it can occur. It can gain oxygen. It bonds with oxygen during this process of the chemical reaction. It can lose hydrogen due to this chemical reaction. Now, these two, gain of oxygen, loss of hydrogen, really important in anatomy and physiology and biochemistry, that chemistry of life. What things are oxidized? Typically metals, fuel, foods, sugars, carbohydrates, fats, the things that we consume to power our bodies. These things are very often oxidized to give us that energy that we need. Bases and hydrogen is something that is oxidized in this process. This terminology can be very confusing, but you will hear it. The thing that is being oxidized is sometimes called the reducing agent. Now, if we go to the other side, the thing that is being reduced gains electrons. It started out as an atom, and it ends up as a negative ion. It can lose hydrogen or gain, I misspoke, lose oxygen or gain hydrogen. Again, very important in biochem, that chemistry of life. What things are commonly reduced? Bleaches, acids, halogens, nonmetals, disinfectants, and oxygen. All of these things are referred to as being good oxidizing agents. All of these things are good at pulling electrons off of other things, and that's what makes them good disinfectants, because of that fact that they have a large electron affinity. So let's take this information and let's look at some chemical reactions and see if we can figure out what is oxidized and what is reduced. So we're going to start with that same rusting of iron and apply what we've just been talking about. Iron starts out as an atom, and after the chemical reaction, it ends up as a positive ion in this ionic compound. It was Fe plus 3 and oxygen minus 2 in order to make iron oxide. Well, Leo the lion goes grr. If you lose electrons, you are oxidized. So the iron is oxidized. It lost electrons, it became a positive ion. How else do we know that iron was oxidized? Well, it's a metal, and metals are often oxidized. If you've got an oxidation reduction reaction, you've got one thing that's oxidized. How do you tell what's reduced? Quite honestly, it's the other thing very often. And so the oxygen is the thing that is reduced. How do we know? Well, oxygen is one of the things that is often reduced. It also gained electrons. Here it started out as an atom. It ended up over here with a -2 charge. It became a negative ion. So it went grrr, it gained electrons, and it was reduced. So you use all of the tools that you've got, you use all of the clues that you have to help pick out what is oxidized and what is reduced. So let's go through another one. Let's say you're burning a fuel like alcohol, but we could be burning methane or propane or gasoline. Here's alcohol burning in oxygen, and I want to know what is oxidized and what is reduced. I take a look at it, and first off, it is burning with oxygen. It is a fuel. Well, a fuel is very often the thing that is oxidized. So I'm going to say this is the thing that is oxidized. And oxygen is typically one of those things that is reduced. So I've identified what is oxidized and what is reduced. Now let's take it further. What is my oxidizing agent? My oxidizing agent is the thing that was reduced. So my oxidizing agent is oxygen. What is my reducing agent? My reducing agent is the thing that was oxidized. That is my alcohol, my ethanol, C2H5OH. And what kind of reaction is this? This is a combustion reaction. And we've been talking about different kinds of reactions. This is a combustion reaction. Combustion reactions will always be oxidation reduction reactions. Let's look at another one. Now, what I'd like to have you do is hit pause and try this one on your own. Okay, here we go. Lithium plus iodine gives you lithium iodide, and this is the kind of reaction that is going to occur in a pacemaker that is going to produce power to power that battery for up to 10 years. What's going on here? Well, lithium starts out as an element, and on this side, lithium makes a positive ion because it is a metal. So it becomes a positive ion, and it's a metal. So good odds, the thing that is oxidized is my lithium. What is reduced? Iodine starts out here. It ends up as a negative ion in this compound. So my iodine is the thing that is reduced. What is my oxidizing agent? It's the thing that was reduced. So my oxidizing agent is going to be my iodine. My reducing agent is going to be my metal, lithium. And what kind of reaction is this? One product, synthesis. This is a synthesis reaction because I have one product. Okay, hit pause. Try this one on your own. All right. Acetaldehyde is converted into alcohol. Both of these compounds are real common in the liver. This is a little bit trickier. Acetaldehyde plus hydrogen gives you this alcohol. Now, my friends, take a look at this one. Acetaldehyde ends up adding a hydrogen to one end. So it actually gained a hydrogen. So this is the thing that was reduced. If this is the thing that was reduced, and what is commonly oxidized, one of the things that can be commonly oxidized is hydrogen. So hydrogen was oxidized, the acetaldehyde was reduced. Now, what is my reducing agent? My reducing agent is the thing that was oxidized. That is going to be hydrogen. My oxidizing agent is the thing that was reduced. My oxidizing agent is going to be my acetaldehyde. And what kind of reaction? This is a synthesis reaction. Why? I only have one product. Okay, my friends, that will do it for this time. Next time we're going to come back. We're going to practice identifying all of these crazy reactions. See you then. Bye-bye.